In this video, let's do some of the theory past paper questions related to the reversible reaction. And the trend tells us that the reversible reaction is, we often get the question on reversible reaction in section B and very frequently, almost every year. So that means this particular topic, as far as the theory past papers are concerned, it's of great importance. So let's do 2 to 3 questions related to reversible reactions. Our first question is from the year October, November 2010, and it's question number 3, right? You can look for this particular question. It says that carbonyl chloride, COCl2, is a colorless compound, poisonous gas, colorless poisonous gas, formed when carbon monoxide and chlorine combine in the presence of sunlight. The forward reaction is exothermic. This is a very important information, and we'll be needing this information when we have to predict a change in temperature, whether the reaction in the change in temperature is going to go in the forward direction or in the backward direction. So we can also write it down along with the equation as delta H is equal to negative. This is going to tell that the forward is an exo, automatically the backward is going to be your endothermic. Okay, so this is a very important piece of information when we will be looking for temperature change and how the temperature change is going to make the reaction irreversible. Now, apart from this, the other information in the question is that they're saying that COCl2 is basically, this substance is basically colorless. Okay, now let's read the A part of the question. It says that predict. Normally these type of questions come with the questions like predict and explain. You have to predict which direction the reaction will go if you're going to bring changes into concentration or pressure or temperature, and then you have to explain your prediction. If you're saying it'll go in the forward direction, then you have to state why. If you'll say it is going to go in the backward direction, then you have to state why. You have to explain why. Okay, so here comes the predict and explain. How each of the following affect the position of the equilibrium. So they are talking about the irreversibility of the reaction, whether it's going to go forward or backward. If number 1 part, increasing the concentration of the chlorine. If we increase the concentration of chlorine, which is one of the reagent, if we increase the concentration of chlorine, then what will happen? We have studied in the previous video where we were talking about the factors that in case we are going to increase any one of the reactant, automatically the reaction will be favored. The forward reaction is going to be favored. Reason is that the reaction is going to move in the direction which will decrease the impact of the increased concentration. So the chlorine's concentration is increased, so the equilibrium is going to move in the direction to reduce the impact of the increased concentration of chlorine. So that means it's going to go in the forward direction. So what are we supposed to write down here? First of all, we'll write about the prediction. All right, so we will write down, we'll predict that the reaction will go in the forward direction, okay? Or the forward reaction will be favored, or we'll say that forward, our prediction is the forward reaction will be favored. Now, after that, we have to explain it. This was a prediction, now explain it. So in the explanation, you write down the reaction will move. Reaction will move in the direction to decrease the impact of increased concentration. Now coming to the second part of the question, it says that increasing the pressure. Now we have studied before, pressure is a factor which is only applied in the case of gases. Now let's see, are they all gases? Yes, there are gases, two gases on the reactant side and there one gas on the product side. If we have a look over here, so increasing the pressure always favor the side with the reduced volume. That was a rule we have learned, reduced volume. It will be favoring the side with a reduced volume. So let's predict first. Now we how many I'm just writing down the equation once again here. So I have carbon monoxide reacting with chlorine giving you CoCl2. Now what we will do here, we will be adding the number of total number of volume here by adding the number of moles. They all are gases, so we'll be adding the number of gases moles on the reactant side. Similarly, we'll do in the product side as well. The 1 plus 1 makes it 2 moles or 2 volumes, and here we have 1 volume or 1 mole. So it says that increase in pressure will be favoring the side with the reduced volume. So 2 volume or 1 volume, which is a reduced one. It's the 1. So automatically my prediction will be, I will be predicting that the reaction, which reaction will be favored. Again, the forward reaction is going to be favored. Forward reaction will be favored, right? Will be favored. Now they're asking the reason also. So I'll write down the explanation of the reason that increase in pressure favors the reduced volume. So that is going to be favors the reduced volume. So that is going to be a 2-mark answer. Coming to the last part, that increasing the temperatures. I told you that for increasing the temperature, we have to look at the delta H value, whether it's negative or a positive. Now they're saying that the forward reaction is an exothermic. So automatically the reverse reaction is going to be endothermic. Now what are they doing? They're increasing the temperature. The increase in temperature always favors the endothermic side, right? So endothermic is a backward. So what I'm going to predict, I'll predict, first point is that I'm going to write down the prediction that the reaction, which reaction? The backward reaction. The backward reaction will be favored. Now comes the explanation that increase in temperature always favors the endothermic reactions. Endothermic reaction or endothermic side. So that is how you'll be answering the reversible questions, the questions which are based on the reversibility on the basis of the Lee-Chatelain's principle. This is another question from May, June 17, and it says that iodine reacts with the chlorine. Just a second. Iodine react with the chlorine to form iodine 1 chloride. That's ICl, right? So the equation is iodine, which iodine reacts with chlorine to give you 2ICl. Right now, further it says that the iodine 1 chloride react with the chlorine to form iodine 3 chloride. The reaction is investigated. This iodine 2 chloride, this is the first reaction, but this is not a reversible reaction. We can see with a single-headed arrow, that means it's not reaction. Now this iodine 1 chloride further reacts with the chlorine to form iodine 3 chloride, but this is definitely a reversible reaction. This reaction is investigated at 200 degrees Celsius in a sealed container. The dynamic equilibrium is established. I explained in my video what is dynamic equilibrium. Now, first of all, let's read the part 1 and then we'll move on to the next step, and certain information is given in the A part. We'll look into this information regarding the colors of the substances when we'll need it. So right now my focus is on the dynamic equilibrium. I told you that dynamic equilibrium, and they're asking us to refer to both the rate of reaction and the concentration change when the dynamic equilibrium is established. So dynamic equilibrium is a state, we call it. The dynamic equilibrium is a state of reversible reaction. Reversible reaction at one particular point, it attains dynamic equilibrium. So what is that state of dynamic equilibrium? The dynamic equilibrium is attained by a reaction when the speed of forward and the backward reaction remains the same. So dynamic equilibrium is a state of reversible reaction when the speed of forward reaction and the speed of backward reaction becomes same. and they're also asking us in the terms of concentration. The speed remains same, and the concentration of reactant and products remains unchanged. It seems, hence it seems there is no net gain in any direction. So when the reversible reaction, they attain this kind of a scenario, we call it dynamic equilibrium. Now, if we want to achieve any one side of the reversible reaction, then we have to shatter this dynamic equilibrium, and we can shatter it by changing the three factors, any one of them. That can be your temperature, that can be your pressure if the gases are involved in the reaction, or that can be your concentration or on the either side. If you make a change in the concentration of the reactant or product, then your reaction can become irreversible. Now, coming to the question, the pressure of the equilibrium mixture is increased. What are they doing? They're increasing the pressure. So the pressure is only increased when you have gases. So let's see, are there gases involved here? Yes, ICl is a gas, chlorine is a gas, and ICl3 is a gas. Yes, gases are involved. So they're saying that pressure of the equilibrium mixture is increased. The temperature is kept constant at 200 degrees Celsius. Whatever was the initial temperature, and they have kept the at which the dynamic equilibrium was attained, they have kept the same temperature, but they have increased the pressure on which the dynamic equilibrium was attained. Predict, again comes the word predict, and explain what will happen to the color of the equilibrium. Now, they're not asking whether the reaction is going to go forward or the reaction is going to go backward, but they're asking in terms of observation, in the terms of color. So now let me write down the whole equation over here. I'll write it down, the equation over here on this side. Okay, the equation is basically, and then I'll write down the colors below that. Okay, so that we are able to understand कि क्या color क्यों आ रहा है. So my equation is ICl plus I have Cl2, which is again a gas. ICl is again a gas, which is going to give me ICl3. Okay, that is again a gas. Now let me write down the color below them. This is basically brown in color, dark brown in color, right? And ICl3 is basically yellow in color. It's yellow in color. Now we have to see which side, जिस side भी equilibrium shift होगा, ये आपका color obtain होगा. अगर product side पे अगर reaction forward जाएगा तो color yellow हो जाएगा overall mixture का. अगर reaction backward जाएगा तो overall color जो होगा वो brown हो जाएगा mixture का. ठीक है? तो let's predict whether the reaction is going to go forward or backward if we are going to increase the pressure. Now for the pressure, we have to look at the total net volume on both the side. So I have one volume here of ICl and one volume here. So I have altogether two volumes of the reactants. Whereas I have just basically 1 mole or 1 volume of my ICl3. Now increase in pressure always favor the side with the reduced volume. So out of these two, I have a reduced volume, which is on the forward side. So if I increase the pressure and it is going to favor the forward reaction, then what is the color of the compound which is being formed due to the forward reaction is yellow. So I will predict that. What am I going to predict? I'll predict that the forward reaction will be favored as increase in pressure favors reduced volume. So the overall equilibrium mixture will turn yellow. All right, so that is what I'm going to explain, write down in explanation. Okay, this is a very interesting question, and we need to look into this question because even the principal's examiner's report says that the students make blunder while reading the question, and specifically this kind of a question. I'm reading the question, it's from May June 14, and the question is, when iron is heated with steam in a sealed container, an equilibrium mixture is obtained. Now they are taking iron and steam, they're reacting together, they are getting hydrogen and Fe3O4. And they have specified that the reaction del is positively, it has a positive enthalpy. That means the forward reaction is my endothermic reaction. Okay, I can interpret from this particular value. Now let's read the A part. It says that describe and explain. Normally क्या कहते हैं, predict and explain. So they are asking you to describe and explain what happens to the rate of forward reaction. Now, many a times students skip on this. Previously, they were asking about the position of the equilibrium. But what are they doing? What are they asking here? They are asking about the rate of forward reaction. They are not asking about the position of the equilibrium. So the rate ke factors kya hai? How do you increase the rate of reaction? The factors are basically again the same. You have the temperature, you have pressure. If the gases are involved, then they have concentration, then you have surface area, and you have catalyst. So basically the first three are the common, which is going to increase the rate of reaction or alter the rate of reaction, and these three are again the factors which change the which are responsible to make the reaction irreversible. So how now they're tricking with the question, instead of showing you the reversible reaction, but they're asking about the rate of forward reaction. Now, I'm reading the question once again. It says that describe and explain what happens to the rate of forward reaction when the temperature is increased. So with respect to the rate of forward reaction, you have to explain that what will happen if you increase the temperature and the pressure remains a constant. So we know that when the temperature is increased, what will happen? When the temperature is increased, what will happen? The particles they are going to acquire, you have to explain and you have to describe. The particles are going to acquire more kinetic energy, which leads in more frequent and successive collisions, leading to faster forward reaction. So you have given the explanation what happens when you increase the temperature, that the kinetic energy acquired by the particle that increases, which leads into frequent and successive collision, which is going to make the faster reaction go at a faster pace, the forward reaction go at a faster pace. So this is a 2-mark question. Remember, you have to read it very carefully. They can trick you asking about the position of equilibrium, or they can also ask you about the rate of forward reaction. Coming to the B part, describe and explain what happens if anything to the position of equilibrium. Now look here, in the part A they were asking about the rate of forward reaction, and then the B they're asking now about the equilibrium shift, position of the equilibrium, whether it is going to go forward or backward when the pressure is increased. So which factor are they applying? They are applying the pressure factor, and we know that the pressure factor is only applied in the case of gases, whereas the temperature is kept constant. So let's see over here, we have an equation that's 3Fe, it's solid, reacts with 4H2O, it's a gas, water vapor, and we have a reversible reaction. Double-headed arrow is written there. 4 hydrogen, and we have Fe3O4, which is again a solid. So basically we have got 2 solids here, and the pressure sif apply hota hai in the case of gases. So that means we are not going to include, when we'll be counting the volume, this is a solid and this is also solid. So when we count the volume, we are not going to count the volume or the moles of the solids. So altogether on the reactant side, how many volumes, what moles of gas are there? So we have 4 volume here. And how many moles of gas are there? There are 4 volumes here. Okay, so pressure will be applied for gas only. So that means the volume of gases on both the sides are same. So because the volume of the gases on both the sides are same, so there will be, no matter whether you increase the pressure or you decrease the pressure, there will be no effect. So what you will write down, there will be no effect on increasing the pressure, on increase of pressure. Why? Because the volume of gases on both the sides, both the sides are same. So this was a little tricky question, which was just for 4 marks, but I hope it's clear now how to write or frame your questions. And before framing your questions, how to read the question, underline and see what is the demand of the question. Are they asking you the rate, or they're asking about the position of the equilibrium being shifted?